Hello and welcome to my Orthographic Projections Part 3. In our last session, we have seen different engineering components. We have seen the front view, side view, and top view for simple figures. But in this session, we will go through the we will take different mechanical components and machine components for which we will try to draw the front view, side view, and top view uh, in first angle projection. Let me take one example in this case also now, and this is the component I am assuming for which I would like to draw front view, side view, and top view. And this is the view I am assuming as an X. That means uh, for this I need to assume, this side as an front view, then I need to draw the left side view, then I need to draw the top view as usual in first angle projection. When you see this figure from front view, we can see we have a cylindrical shape here, and this is located on the rectangular block. So when you see from the front, you will see one rectangular block. Then we will have another rectangular block for the cylindrical shape. When you see the cylindrical shape from in front view, we can also it looks like a rectangle shape. The curved shape you cannot observe when in the front view. It looks like the rectangular shape only. And similarly, you will get one triangle shape in front view. That triangle is attached to the rectangle shape with the given dimensions. So this is actually the front view for which I need to assume all the views. Now let us see, first we will get a rectangle block as I said just now, then we will get another rectangular block over this rectangular block. This is the cylindrical shape. Then this cylindrical shape is connected to the rectangular block with a triangular web. So that looks like a triangle shape which connects the cylinder and as well as the rectangular block like this. The dimensions are not given in this three-dimensional figure, but whereas in while drawing the front view is taken the dimensions, you can assume the given dimensions by looking into the front view, side view, and top view also. By looking into the front view of this three-dimensional component, we can say that the height of this cylindrical shape is 40 and the height of this rectangular block is 10. Then the cylindrical block is located 45 from the right side of the block like this. These are all the dimensions we require, and also we require the length also. So this will be given in the next views. Let us see. After drawing this front view, I think, okay, let me take one pen to see what exactly the figure now. Okay, now this is exactly the front view. F1 I am taking. This is the phase 1, and similarly this is phase 3. Okay, and this is, otherwise you take this phase 1 and phase 2, then this is phase 3. Totally in front view we will get 3 phases. One is this F1, then over F1 we will get one F2, then finally we will get F3 triangular surface. As you can see, this is our F1, then this is our F2, then finally we have one shape that is triangular shape. This is F3. This is exactly the front view of the given component. Then let us try to draw the top view. Before drawing the top view, I will tell you that in top view we can observe this face. This is, I am assuming, as T1. Then this face you will get as a rectangle shape, and you will get one circle. Then we will get one rectangular shape. Then finally we will get these two shapes are located on T3 face like this. On T3 face we will get one circle and as well as one rectangle shape which connects the edge of this rectangle block and as well as the cylindrical shape like this. Now let me move further to see how the top view looks like this. Yes, as I said just now, you will get one rectangle shape, and exactly this is our face surface T3. Then this is T1, and T2 is connecting T1 and T3 like this. That means this T2 represents the web of the component which connects the cylindrical block and as well as the rectangular block. Then let us try to draw the side view. Okay, but in this case he is not asked the side view, he is asked only front view and top view. But let me draw the side view for this. So I would like to draw side view for this, side view for this. So when you see this component side view, it looks like this. Okay, so when you see from this, you will find this shape. I'm assuming this as S1, then I'm assuming this as S2, and finally you will get one shape that is S3 here, and we will have one more rectangular shape here which is hidden here, that is S4. Okay, now let me extend the lines here, let me extend the lines here. Then with a given width, so the width is 50 here, so with the width 50, so let us draw a rectangle here. So this width is 50 as it is given in top view. So you take this value as 50, and with 10 mm height, 50 mm length, draw a rectangle and extend these lines from the front view. So then let us draw a center line here. Let us draw a center line, so which is at 25 mm from this edge. Then draw a rectangle with the diameter 30. So 50 mm here, then 50 mm here. So that means the diameter of this cylindrical block is 30, so that I am placing this cylindrical block at the mid of the rectangular block from the side view like this. So that means this diameter is 30. So the diameter of this block is 30. So with diameter 30, place a rectangular block because the cylinder looks like rectangle in front view. Then we have one web here. So this is also located at the mid of the block like this. The thickness of this web is 10, so that 5 mm to the center line like this, 5 mm to the center line like this. Then this width is 10 mm. The thickness of this rib is 10 mm, which is located at the mid of the block from the side view. It looks like this. This is exactly the side view of the given mechanical component. Now let me move further to see the next component. Let me take another example. This is and as another example we will consider. The front view of this component is, I'm assuming this is an X face like this. Yes, this is the front view as it is indicated in this slideshow. Also, I'm also assuming X the same direction. Then this will become your top view, right? This will become your top view, and side view is not given in this slideshow, but I will draw this side view to this component also. Now let me draw the front view first. If this is X or front view that I am assuming as front side, you will get one rectangular block here. So I am taking this as F1. Then we will get one more face like this. This is F2. So on the top we will get one curve. Then this rectangular shape, on the top we will get one curved shape like this. Then finally this face we cannot see. This will be shown only on the top. This face will be shown. And similarly we will get one more shape, one more face here. This is F3. In front view of this component we will get three faces. One is F1, F2 and F3. Let me see how it looks like this. Even we have one corner of this rectangular component is a fillet, but even though it looks like a straight line here in the front view. Yes, draw a XY line, then draw a rectangle. This is F1 here with a given length and width, height, with a given length and height. This is exactly F1 here. The height is 10. Then length will be given in side view. Let us see in top view otherwise. Then as I said that we will get one more shape. This is exactly F2. And on this we have one curved shape, cylindrical hollowness, that we will get a semicircle here. Then finally we will get one more shape F3 here. Totally we have three faces and we have a hole here at a certain distance. So this hole looks like a dotted line like this. So this hole looks like a dotted line like this. This must be shown as a dotted line because we cannot see this hole in front view. So that we need to represent this in dotted line. Then let me move further to see the top view. As I said, the length of this component is 100. It is not mentioned in front view and as well as the three-dimensional component. Hence take the length of the component as 100. Overall length of this component is 100 from here to here, which is not mentioned in the three-dimensional component. It is mentioned in front view and top view. Then draw the top view. In top view you will get one face here. I am taking this as T1. Then similarly we will get one shape here. Even though it is a circular cylindrical shape, it looks like a rectangle. To this rectangle we will have small rectangle beside to this T3 I am assuming. Then this face you will get T4. This is L-shaped T4. Okay. Then finally we will get one circle here, T1, T2, T3, T4, and we will get one circle here. And similarly we will get one curved shape here. To this rectangular block we will get curved shape. T1 we have a curved shape at the top left corner. Okay, that you can see here. So we have this is our T1 face. When you see this component from the top, the surface that you can see is T1. Then you have a cylindrical shape that is T2, and beside to this cylindrical shape we have another rectangular shape that is T3, and finally we have, but we don't have this line, please make a correction. Then this is T4, and similarly we will get one circle here. As you can see, the radius of this hole is 30. The radius of this hole is 20. The radius of this hole is 20 and radius of this fillet is 30. This is exactly the top view of the given component, engineering component. Now let us draw this side view. So when you see this component from left side, you will find this shape S1 is in L shape, then this edge and this edge will coincide, these edges will coincide so that we cannot see this face. Similarly, we can find a rectangular shape S2 above this rectangular block S2, and even though we have a curved shape here, fillet here, it looks like a rectangular block when you see it from side. Then we will have one dotted line here in the side view also, because we cannot see this hole. Hence we need to represent this hole as a dotted line. Similarly, we have a cylindrical hollowness here, depression here. We cannot see this depression, so that we need to represent this depression also as a dotted line with the radius of this cylindrical depression. Now let me draw this first. So with a given width, so the width is 50 here, that you can see. With 50, so draw a rectangle, then to the left side with a thickness 10 and draw, and we don't get this line. Exactly L shape we will get with 10 mm thickness. Then we have this thickness 10, 30, then totally we have 40 here. So with 40 mm, so this length is 40 and this is 10. So as you can see here in top view, it is 10. The cylindrical shape is 30. Then again we have 10. Up to here, we need to represent or 10 and as well as 30. Totally we have 40 here. Then 10, 30 and 40. Up to here, then drop a vertical line here. This represents S2 surface and this represents S1 surface. As I said, you cannot see this hole from front, so that we need to represent that as a dotted line like this exactly at the mid of this side view. Similarly, we can also see the depression of the cylindrical shape that also needs to be represented as a dotted line like this. This is exactly the side view of this given component. Now let me move further to see another component. Exactly, take this is an example. Then this is the front view of this component. Yes, exactly. Is also assuming the same front view at this location. And this will become the top view for this component. Now let us draw the front view first. In front view, we will get two circles. So one is this in front view. In front view, we will get one rectangular face, even though it is a cylindrical surface. It looks like a rectangular surface. This I am assuming as F1. Then we will get one more rectangular face. This is F2. But inside the rectangular face, we will get one more rectangle with a given width and height. Then we will get one frustrated or truncated cone like this. Now let me move further to see. As I said, we have one rectangular face, that is F1. The height of this rectangular face is 10. Then we have a hollowness inside this cylindrical surface. That hollowness is 10. That also needs to be represented. The height is 35. The height of this hole or the depression is 35. Then the width is 10. With the given dimensions, represent this hole also. Then draw a rectangular shape. As I said with you, the height of this cylindrical shape is 50, so that we will get a rectangle with 50 mm height. Then, as I said with you, we will get one more truncated cone with the given dimensions. The height is 30. The diameter is not given, but in the top view it is represented. The diameter is 20 here. The height of the truncated cone is 30. Then on the top the truncated surface diameter is 20. This is the front view. Then in the top view we will get, this is f2, and you take this as an f3. So this will become f2, this will be your f1, and this will be our f3. Similarly, we have one slot here. That slot is located exactly at the mid of this cylindrical portion, like this. The height of this slot is 35 mm and width is 10 mm. This is exactly the front view. Then when you see this component from the top, we will get this T1 surface. Then we have T2. These two surfaces looks like the concentric circles. Then we have another circle, that is T3. Totally we will get three concentric circles with this diameter, three diameters. Then we will get one slot. This slot we cannot see from the top, only front we can see this slot. So that we need to represent this slot as a dotted line with a given dimension, that is 10, exactly at the center. The slot is located exactly at the center of this cylindrical portion, hence that needs to be represented as a dotted line exactly at the mid of this cylindrical portion. The width of this slot is 10. As you are aware, this is also given in front view. Then draw a circle with 20 mm diameter, then draw a circle with 30 mm diameter, then draw a circle with 60 mm diameter. Finally represent the dotted line for the given slot in the cylindrical portion like this. This is exactly the front view and side view of the given component. As you can see, this is the front view and top view. Now let me take another example. I am taking a block, very simple block. This is also, and I am assuming the front view from this side, then side view here. Top view is not asking top view in this case. Then we will draw the top view for this. We will try to draw top view for this, but in this slideshow is not drawing the top view, but we will draw. Then this is exactly our front view, and this is side view, and this is our top view. When you see this component from this side, from the front side, we can observe this face. Similarly, we can also observe this face, F2 I am assuming. Then we will get one line here, dotted line here, because we cannot see this slot from the front. This slot can be observed, can be seen only from the front and from the top and side views only. Front view we cannot see this slot. This slot can be observed, will be represented as a dotted line. So we will get one dotted line like this. Now let me draw the front view like this. As I said with you, we will get one dotted line like this. The length of this block is 80. Then height is 50. This is given in side view. Okay. So 80 and 50, draw a rectangle, and the web depth is 25. This is also given in side view. With 25 mm depth, draw or represent the slot given in the block. Then On the top of this rectangular block also we have one small rectangular block that is 25 mm width and 25 mm height. 25 mm width and 25 mm height, that is also given to us. This is our front view of the given component. Now let us try to draw this side view. In side view, when we see this block from side view, we can observe this face S1 I am assuming. Then we will also get this face S2 I am assuming, that face. And similarly this S3 you will get. In side view we can see total faces. Those are 3 surfaces we can see. So this is our S1 as you can see here. Then you have S2 here. Then similarly S3 here. The total height of this component is 75. Initially you will get the width of this block is 25. This is 25 and the length of this block is 80. This is given in the problem itself. By taking 80 and 25, draw a rectangle in front of you, represent the dotted line, then represent the web above this rectangular block with the given dimensions. Then from the left side view, you will find the surface S1, S2 and S3 looks like this. Then let us try to draw the top view for the given component. When you see this component from top, you will observe this face. I am assuming this as T1. Then we have this surface T2. Then similarly you will get the surface this T3 and this side also we will have T4. So these faces we can observe. Okay. Then let me draw the top view, and top view will come at the bottom because it is the first angle projection. I will draw a rectangle with the given dimensions 80 and 25. I'm drawing 80 and 25 like this, and we will have one block here, so that is 25 here, that is 25 here, and similarly we will have another 25 here, so 25, and finally we will have 25 here. This is 25 as you can see, and this is also 25 height and 25 width, height and 25 width, then 25, okay, 25, then in the top view it looks like this only. This inclinedness we cannot observe in top view, it looks like that only because it is also 25. So same thing looks like this. It looks like a rectangle. We cannot observe the inclined surface in top view. Then we will also draw a center line like this, then represent this is exactly. So drop this line like this because we have at the 40 and the width is not given in this case, but take the width as, because this is exactly at the center and it is 25, it is 25, then take this value as 25 and take this as 8 mm, and similarly you take this as 8 mm, and from 8 and 8, So 8 and 8. Then draw a rectangle up to the line. It looks like a rectangle like this. This is exactly the top view of the given component. Front view, side view, and the top view will looks like this. Now let me move further to see another component. Take this as an example, and I am assuming this as front view or X for this component. When you see this component, or when you assume this component, this as front view and this as top view, the front view, in front view we will see this surface, then we will have another surface, that is F2, which looks like this. With the given dimensions, represent face F1 and F2 like this. The values are given to us. As you can take, the length of this block is 55. This needs to be given in three-dimensional figure to draw this component. The total length of this block is 55 and height is 40. With the given dimensions, those are 55 and 40, represent this one. Then represent the top view also. The circle diameter is 30. Then the angle also needs to be given. This is also 45. Okay. Then draw a circle, represent the top view. In top view we can see this face, even though it is an inclined surface, but it looks like a circle only with a given diameter. This is 30 diameter. With a 30 diameter, draw a circle, then represent the rectangle with the given dimensions. Otherwise, drop a line here. So we will get a rectangle here, and finally we will get another rectangular surface. Even though it is inclined surface, it looks like a rectangle like this. So finally we will get this as T1, T1, and I am taking this as a T2. This is our T2, and similarly we have another face, inclined face, which you cannot see in the three-dimensional figure, that we have another rectangular face that I am assuming as T3. This T3 is represented here. Totally we have T1, T2 and T3. It looks like this. Then take another component. I am assuming this as X for this component. For this figure, front view and side view of the component, top view is not asking. In front view, we will get this face F1, then we can get another face F2, then we have F3. Finally, we will get a dotted line here. Then we will get another dotted line on F1 face like this with the given dimensions. Then draw an XY line first. The height is 20. This slot is exactly at 15 mm from the bottom, so that this should be represented as a dotted line. Then this line will not be there, same surfaces, so that you will get a rectangular block at the mid of the block. Then we will get one dotted line like this. With the given dimensions were represented, the length is 100, the height of the rectangular block is 20, the slot is exactly at 15 millimeters from the bottom, the top web height is 40, width is 20, We also require this height. With a given height, represent the slot as a dotted line in this case. Then when you see this from the top, it looks like this. You will get side. When you see this block from the side, it looks like this. This is S1 I am taking, and this is S2. Totally we have two faces and no dotted lines. As you can see, the height is 20. Then the width of this slot is 50. Total width is 60. Totally it is 60, and this slot is 50 like this. Then the bottom of this slot is 30. From the mid, it is 15 to left and 15 to the right, and from here it is height is 15 here. Then from the center it is 25, and up to here it is 25. With the given dimensions, totally we have two surfaces here. This is S1 and this is S2. This is exactly the front view and side view of the given component. Now let me move further to see another component. This is the front view, I am assuming, for the given component. Then when you see this component from the top, you can observe this rectangular face, and in between that we have one slot here. That slot also we will observe, but this face also we can observe in front view. Totally we will get three faces in this rectangular block. Above this rectangular block, we can also see another face with the given dimensions. I am assuming this as F4 like this. Now let me move further. This is the top view. You can observe what I said just now. This is our F1, this is our F2, and this is our F3. The given dimensions represent the three rectangles. In this case, the height is 10. This on the top, we have one another web. The dimensions are also given to us. This is 40 and this is 20. This is 20. So with that dimensions represent this web also. This is our F4. Totally we have four faces. When you see this component from front, F1, F2, F3, F4, these you can observe on the three-dimensional block also, as well as in the view also, orthographic projection also. Now let us draw the top view. When we see this component from top, we can see this surface, I am assuming is as T1. Then we can see this surface T2. Then this surface you can see. Totally we can observe T1, T2 and T3 only. Now let us see. This is our T1. Then this is our T3. Similarly, this is our T2. We can drop a line here to get the dimensions of this T3. Then drop a line here or project all these edges to get the dimensions of the T3 face. T1, T2 and T3. All this is given to us. This is our front view. This is our top view for the given component engineering component. Now let me move further to take another example. I'm taking this as front view for this component, this as X. When you see, okay, so this is not X, this is might be side view, okay, and this is the front view, okay. When you see this component from from this side, we can observe this face F1 and this face you can observe F2. From this side, we can only get two faces with the given dimensions. It looks like this. This is our F2 face and this is our F1 face. These dimensions we can observe in side. Okay. The side view, when you see this component from side, it looks like this. We will get this face and S2. Finally, we will get a dotted line exactly at this location. Dotted line. It looks like this inside view. We can observe here, this is our S1 triangular face, triangular surface. Then we have this S2 with the given dimensions. The values are given here. Then we have one edge here which is backside to this component that can be showed as a dotted line like this. This edge we cannot observe, we cannot see from the side, hence we need to represent that edge as a dotted line like this. This is exactly the front view, this is exactly the left side view for the given component. Now let me take another example. For this is front view X. Then for this is asking front view and side view. The side view is exactly from here. When you see this component from in this view, we can observe this F1 face. Then we will get this face also. One rectangular face at the bottom. One face which is above. The rectangular block looks like this. Then we will get one dotted line here because we have a slot in the middle of this block. Then these two dotted lines we will get on this F1 surface. Then draw XY line. Then you can see here, as I said, we have F1 here. It looks like this. Then we have F2 here. Then I said with you, we have two dotted lines which you cannot observe. Those slot edges from this side, those must be represented as dotted lines like this. Then when you see this component from top, we can observe this face S1. Then this is our S2. We will get a U shape here or a C type shape here. Otherwise, we will get this shape here with the given dimensions. Then S1 and S2 are the surfaces that we can observe when you see this component from left. It looks like this. One trapezoidal surface, that is S1. Above that, one C block is placed which looks like this. As you can see, one trapezoidal face, that is S1, and above this trapezoidal we have a C shape like this. This is the front view and left side view of the given engineering component. Then this is what the front view, side view of the given engineering component in first angle projection. This is not having any curved surfaces. Then representing dotted lines will play a key role while drawing the front view and side view. The edges are the surfaces that you cannot observe. The edges, those edges needs to be represented as dotted line. That is very important while drawing the orthographic projections. Most of the people will forget to represent the edges which you cannot see from the side view or from the top view or from the front view. Then we have seen this shape. Then this figure we have seen a cylindrical block which is sectioned by a plane of 45 degrees that we have seen, which is placed on a block like this. Then we have seen this figure we have seen. These are all the figures that we have seen in this session. But in the next session, we will discuss the projections of the points, lines, and planes. Is as of now we are projected the solid components on the surfaces, on the planes. When we place a component in the first quadrant, we have projected the views onto the different planes. Now, in the next class, we will try to project the points. When we place a point in the first quadrant or on the horizontal plane or before the vertical plane, we need to draw the projections of the points. The point can be at a certain distance from the horizontal plane or from the vertical plane, or the point can be lie on the horizontal plane or at a distance from vertical plane. In different conditions, we will try to draw the projections of the points when it is located in a plane, when it is located in a quadrant. The values will be given to us, the location of that point will be given to the location of the line will be given to us, the projections of the points, projections of the lines. When we place a line in a quadrant which is making certain angle with HP, horizontal plane or vertical plane, or maybe line can also make certain angle with HP or VP. And similarly, a plane can also be placed in a quadrant which can also make an angle with the horizontal plane or vertical plane. In those cases, we will try to draw the projections of the points, lines, and planes in the next session. Thank you one and all for this session. We will meet you once again in next session to discuss the projections of the points, lines, and planes. Thank you.